Okay, for today we're starting on the file that I have under course information, which is called the template, the unit circle template, or the circle trig template. And I asked you to find pi over 6. Basically, pi over 6 is an angle of about 30 degrees, and hopefully you made that your spots. Raise your hand if you had that right. Okay, good. Then I said make a triangle out of it, so I'm hoping you figured out I meant drop it down there, and there's a triangle. Okay, there's other ways, I know, but this is the way that you're going to be doing it. You'll always start by drawing a ray. You get, like if I had said 330, you'd have to draw a ray like out here. You always start with drawing a ray from the center out, and then you'll always make a triangle out of it by drawing next a vertical line. Okay, so if I'm going to make a vertical, that's not vertical, that's horizontal. So, oh, I'm not that way, this way. Okay? Okay, so now, if this is truly this pi over 6, have you figured out yet that pi over 6 means like 180 over 6, which means it's like 30 degrees? Does that make sense to you? That's a 30-degree angle. Then do you get we have a 30, 60, 90 triangle? All right, so then label the angles and label the sides. If this is truly a 30, 60, 90, we'll label the angles and label the sides. Okay, well, if this is like pi over 6, it's like 30, and then this is like 60, and this is like 90. Nobody calls it the pi over 6, pi over 3, and pi over 2 triangle. We call it the 30, 60, 90 triangle, right? So I'm just going to use 30, 60, and 90. And then I'm going to have 1, 2, and the square root of 3. Why doesn't this match up with our framework that we have? Like you drew it onto a circle that has already got some labels and stuff. Why doesn't this match anymore? Yes, sir? The radius is supposed to be 1, and what do we have as our radius right now? 2. Okay. But that's okay. It's still giving us reference angles, and this is still a ratio of 1 to 2. So if this is supposed to really be a 1, then what's that actually? 1/2. Okay. So you're saying the height is 1/2 right there, aren't you? So isn't this spot right here have a height or a y of 1/2? Does that make sense? And if all of these are half as big as what they're supposed to be, because again, I'm forcing this to only be 1 instead of 2, then I'm making it half as big. Do you get how I'm dividing that one by 2 also? And do you get how my x is √3 over 2? That's this x distance. For this point right here, that's the x and that's the y. So the x distance is √3 over 2. I just found a spot on that circle by using trig. That spot in space would be √3 over 2, some decimal, comma, 1/2. All right. Now we're going to extend that a little bit by actually making it more generic. Would you just draw me a triangle? I got 15 of these things. Go to the next circle. Go get a clean circle. This is why I didn't make you do this all on one circle, because you wouldn't have to keep erasing it. You can keep your notes this way. Would you make this one more generic? What would you say this distance is right here? Because you don't know exactly what that angle is. What's that distance? X. Good. We don't know for sure, so we call it x. But it's definitely an x distance more than it's a y distance. And how about the blue distance? The blue distance has got to be y. It's an up distance. And then how about that radius? How long is that? How do you know it's 1? Because it says so, like right here. It's telling you that those dots are at 1. They're always 1, and therefore it must be a radius of 1. I agree. So if this is my unknown angle, looks to me like it's like 28 degrees, but anyway, if that's my unknown angle, how would I describe sine of that angle? Sine is opposite over hypotenuse, right? So y over 1. Sine of this angle is y. And isn't y divided by 1 the same as just y? Do you get how the sine is the y distance? This is sine. I know that's kind of weird. Stretches your mind. You can have a lot of that today. Prepare for mind stretch. So if this point is supposed to be x comma y, then generically, we don't know what the angle is, and so we don't know for sure, but what's y equal to again? I mean, if this is supposed to be x comma y, what do you just figured out what y is? Y is sine. Okay, now go back to cosine. In this triangle, what's cosine of that angle? Cosine of the angle would be x adjacent over hypotenuse x over 1. So cosine of the angle is x. So this is cosine. That spot is cosine, comma, sine. How do you know what? We don't know what x is. That's why we're doing it generically. We're using just x. Well, think of it this way. This point right here, if I want to figure out where it is in space, I have to say it's over x. I don't know how far, but it's over this far, and it's up this far. Okay. And so x and y are unknown, but if I leave it all in unknowns like this, it actually leads us to a kind of an interesting conclusion that any spot on this circle, pick that spot, it's what comma what? It's cosine of the angle, comma sine of the angle. Because I just did that generically. It could work for anything. Any spot. It's cosine, comma sine. So I'd like you to try to remember these two things. Sine y. Why is it sine? Sine, y. Get it? Y, sine, sine, y. Sine goes with y, and cosine goes with x. Cos x. Sounds kind of naughty, but. All right. Sine y, cos x. All right. So then, let me ask you a different question. What's tangent? Go back to this triangle here again. What's tangent? TOA, opposite over adjacent. Yes. Y over x. So I need to make room for one more here. I'm going to unbox these and throw in one more. Tangent. Everybody get these written down. These are big. We're learning big stuff here, whether you know it or not. Tangent of an angle is y over x. Now, just a second. Isn't y sine and isn't cosine x? And so isn't tangent really equal to sine over cosine? It is. That's one of the cool things about trig is that it all boils down to sine. Now why? Because cosine is just sine except shifted over. And tangent is really sine over cosine. So tangent is just a made up thing based on sine and cosine is just made up based on shifting sine, so it all comes back to sine. Sine's the big one. Okay, it's the mother function, the true mother function. Okay, so if I was able to figure out that this point in space over here was at -1/2, comma, √3/2 or something like that, do you get that the angle that goes with it would be telling me the sine of that angle? So if I, for instance, wanted to know the sine at this spot, sine's y, right? The sine of that angle is √3/2. And the cosine of that angle is -1/2. All right, go to another one. Go to another blank one. Actually, for just a second here, you can just observe for a moment. What I'm trying to pull together right now is that if it's all based on sine, I just proved that to you, that everything is based on sine, and sine oscillates back and forth between how high does it get? Well, and how low does it get? Very good. Then, do you get that sometimes sine should come out negative? Do you get when you were doing baby trig that it was always right triangles and they never came out negative? The angles were always positive, and the answers were always, we never had negative angles, and we never also had negative answers. They were side lengths of a triangle. They can't be negative. Well, if we put it in 3 dimensions like this, when I have a triangle, it's now like this. Do you get one of my sides can be negative? This distance right here is negative. This is negative, like negative, 0.8 or whatever it is. But that's a negative distance because it's going that way. So now do you get how that can lead me to have negative answers? Go back to this. Do you get that sine goes forever in both directions? Sine just keeps going forever. In the past, you couldn't do sine of 90. But is there a sine of 90? Yeah, you just didn't know how to do it. Just so you know, for future reference, we'll be graphing these things. And that spot right there is 2 pi. And that's where sine completes one full cycle. It started at 0, goes all the way up, all the way down, ends back at 0. It's completed one full cycle. Okay? But that's just one of sine's many cycles. It goes forever. So if I was asking you, when is sine equal to 1? That's one of the spots. That's another spot where sine is 1. That's another spot where sine is 1. And doesn't it have an infinite number of answers? It does. So we're trying to move you from triangles where you only had a few answers that you could get, and you couldn't get angles bigger than 90. Now all of a sudden we can have angles as big as 2 pi, which by the way is how many degrees? 360. And then add another 2 pi to that, 720. That'd be like out here. That's at 720 or 4 pi. So we can have unlimited angles now. So instead of having you graph these and having you go like way, way, way to the right to get to like angle where it's 840 degrees or whatever, we have a circle where you can go around and around and around the circle and therefore go forever. Does that make sense? That it can go forever with a circle? You just keep going around? Okay. So this is how you can handle circle trig. This is how we can finally get answers of where sine is negative, or when we have negative angles. And by the way, negative angles back on my graph here were this way. Aren't there just as many negative angles as there are positive angles? Yeah, the positive angles were going out this way. This is pi. This is pi over 2, also known as 90 degrees. That's also known as 180 degrees. This is 3 pi over 2. But positive is going this way, negatives are going this way. And there's just as many negative answers over there as or negative angles as there is positive angles. It's just you never could draw them in triangles before. All right. So the new task really is to say, if I asked you for what is 120, you should be able to say, oh, I can do 120. Everybody's drawing where they think 120 is. Is it like that? No, it's not. But try to figure out where 120 is. Draw it in on one of those circles. Okay, I'm going to rotate this guy around until he's at 120. Would you agree I'm at 90 right now? 110, 120, okay? And then, being evil, I expect you to know that in radians. Like no big deal. 120, isn't that 260s? Right? So what are 60s? Pi over 3s. So it's 2 pi over 3. Now I know 120 you could go off and convert it by multiplying it by pi over 180, but it would be a lot faster if you could do that and say 2 pi over 3 instead of having to convert it like that. You'll get better and better at that. But if this is 2 pi over 3, 2 pi over 3, it's actually this angle. Just as much as that was 120 degrees, it's also 2 pi over 3. But in the past, we could never make a triangle like this with a 120 degree angle in it, and we still can't. Can't make a right triangle with a 120 degree angle in it. But do you get how we could drop down here? Remember how I always said you're going to always go vertical? Everybody draw in this triangle right here. And we aren't going to need a 120. Instead, we're going to use what's called the reference angle. The reference angle is this guy right here, 60. I happen to know the ratios for a 60. I got that one memorized. If that's 60, this is 30, and that's 90. And again, nobody's going to do it in radians. It's a 30, 60, 90 triangle. So if it's 30, 60, 90, do you get that the side ratios are 1, 2, and the square root of 3? Except, wait a minute, our radius is supposed to be half of that, right? So why don't we just divide them all by 2? Divide by 2. 2 divided by 2 is 1, right? Divided by 2, that's 1/2. And divided by 2. And guess what this point is right here? What, comma, what? What's that point right there? Negative 1/2. A lot of people would have forgot that. Nice job on catching the negative. Negative 1/2, comma, root 3 over 2. And now, since sine y, sine is the y of that, you get that the sine of 120 degrees is root 3 over 2. Now, if that was too much for you, I'll do the sine the old-fashioned way. Sine of this angle is opposite over hypotenuse. That over that. And 2 over 2 is really 1, so it's really this divided by 1, which is really that. There. Does that work better for you? Whichever you'd like. Okay, so what's the cosine of 60 degrees? I know it. Boom. What is it? Because that's cosine. Cosine is x. Could I have also done it by doing cosine of this angle right here? Yeah, cosine is that over that, which is 1/2 over 1, which is 1/2. Do you get how we're made a triangle that doesn't really have a 120-degree angle in it? We kind of faked it. We made a triangle. To answer the question about 120, we made a triangle that was back to our 30, 60, 90 triangle again. That's why those are so critical. All right, let's see if you can do one. Again, go to a brand new one. I made 15 of them. You should have plenty left. This time I'd like you to find 150 degrees. Swing this arc to 150 degrees. Wherever 150 is. And I'd like you to figure out for me what the cosine of 150 degrees is. You'll draw a little triangle. And you can make this as simple as go back to your days of using the 30, 60, 90 triangle or the 45, 45, 90 triangle. As long as you know those side ratios, you'll be good. I'm asking you for the cosine of 150. By the way, wouldn't that have been the same thing as if I had asked you for the cosine of 5 pi over 6? 5 pi over 6 and 150 are the same thing. Think of it this way. This is 5 times 30 degrees. And 30 degrees is a pi over 6. So it's a 5 pi over 6. That's a way to think of it. You got to find your own way. But if I'd asked you for the cosine of 5 pi over 6, you should have found that same spot right here. And if this is 150, that means this is 30. And really, I got a 30, 60, 90 again. And if this is a 30, 60, 90, and this is a 90, and this is a 60, normal reference numbers would be 1, 2, square root of 3, but what should I do to all of them? Cut them all in half, divide by 2, divide by 2, divide by 2, and now, what's so easy to forget that I have wrong right now? Negative. This is a negative number because it's going to the left. So this spot right here is what, comma, what? What's this? Negative root 3 over 2, comma, 1/2. And now from that, sine y, what's the sine of it? A half. What's the cosine of it? Negative root 3 over 2. That's my answer. I want to do it the old-fashioned way instead. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And therefore negative root 3 over 2 over 1, which is negative root 3 over 2. Do you get how you can now answer any positive or negative angle, and you can now get answers that come out negative. Not just negative angles, you can get answers that are negative. All right, so your mind is expanded. Now, if you do this with all the common angles, do you get not everything's going to work? Like I can't find sine of 29 degrees from this. But I can do the common ones. What are the common ones? 30, 60, 45, and 90. Those are the common ones. But then do you get every one of those has a reference angle that goes with it? And therefore 30 kind of goes with a 150. So you can find the sine of 150 because it really is going to boil down to a 30, 60, 90 again. So you can find all the biggies. And when you put them all together, you actually have something incredibly powerful. In fact, I think it's worthy of a big reveal. So, what I'm about to show you is going to change how you see trig forever. It'll change how you see math forever. Those three little buttons, sine, cosine, and tangent, they're never going to be the same for you again. Right triangles, they're not going to hold you back anymore. You'll be able to go beyond. You'll be able to make angles that are incredibly, ridiculously large. You'll be able to get answers that are incredibly negative, where you never could before. What I'm about to show you sums it all up, all in one place. And in fact, if you could memorize it, what I'm about to show you, but I haven't shown you yet, this would give you all the answers for all your test questions for the rest of this year. Pretty much. All in this one diagram. Is that possible? Yes, it is. Behold the unit circle. That contains so many patterns. It's actually amazing. Here's my little 30-degree angle. Do you get that can reflect over here? And it's the same numbers, except negative, and then it can reflect down here. Same numbers, except both negative. All the way back over to here, same numbers again. Oh, the patterns, they're so rich. You could just savor this moment. This thing, if you really understood it, can explain all of those waves, all of the asymptotes, all the times when the answer can't be done. It will make sense once you understand this. So, am I saying you should memorize this? Well, in a way. How about this? Wouldn't it be handy if you knew what 9 times 8 was? 72, yeah. I mean, it was kind of nice so you did not have to go type that in on the calculator, right? So if a kid was taking the ACT and they asked you, do you think I'll need to multiply for the ACT? Could you see how the argument could be made? Now, you don't really need to know 9 times 8 because you'll have a calculator. But do you get a kid who knows their times tables will be like way ahead of somebody who doesn't? My point is, if you've got this memorized, it's comparable to you knowing your times tables. You'll be able to fire things off like, well, yeah, 9 times 8 is 72. 72 divided by 2, 36. I can do that in my head. Boom. As opposed to I can look it up on a calculator. My point is, if you have this thing memorized, when I say what's the cosine of 300 degrees, you'll be like, oh, cosine. God, Jason over hypotenuse? No. You'll say cosine is x, and here's 300, and there's x, and therefore the answer is a half. Boom, done. And notice it's even positive a half. Or when I say, what is the tangent of 225 degrees? Tangent? Tangent, I can't even do, oh yeah, tangent's y over x. So here's 225, here's the y, here's the x, and they're identical. And when I divide them, what's the answer? 1. You see how you can get every answer from this? It's ridiculous if you know them all. So, these are the exact same thing as these. are the exact same thing as these. Are they the exact same thing as these? They just have negatives in different places. And so now, one last thought. All of the functions will be positive here. Think about this. Do you get that since sine is y, they're all positive here, but only sine is positive here? Only tangent is positive here, and only cosine is positive there, and that's why all students take calc. ASTC, memorize it. All students take calc. So when I say that tangent is negative, you can be like, well, if tangent is negative, it can't be here because all of them are positive. And if tangent is negative, it can't be here because that's the place where tangent is positive. So you must be saying the answer is either here or here. So much to know from this one diagram. All right. So if you could just memorize this, it would help you so much. It would not just instantly solve all your problems, but if you memorize it and you understand what the powerful tool that you have in your brain, you can use it to solve almost everything. Why do I say almost? Because this only works for the biggies, like 30, 60, 45. It doesn't work for a 59, does it? All right, so I need to show you just one little thing about that so that you can answer a couple of the questions in tonight's homework that don't come out nice. Like if right now, I should be able to ask you any of these. Sine of 135, which by the way is the same as 3 pi over 4. Sine is the y, right? So it's right there. All right. In Schoology right now, you have this big, beautiful diagram. It's the exact same one. I found the best one on the internet. And it's there for you. If you go into Schoology right now and find under course resources, find the unit circle, Open it up. That will be so handy to know. Can you just have a copy on your next test? No. It would be incredibly too powerful. But can you memorize it and then write it on the side of your test? Absolutely. When you realize that it's really just a repeat of these three numbers, and these numbers we can get by doing a 30, 60, 90 triangle and just dividing by 2. That was my 30. 1, 2, square root of 3, divide by 2, divide by 2, divide by 2. That's where the numbers come from. Then it's really not that hard to memorize. All right. I hope you see the beauty and the potential. And right now, everybody get that up on your screen, and I want you to turn it my way to show me that you found the unit circle. And I'm still waiting for 5 people, otherwise it looks like pretty much everybody has it. 4, 3, 2, 1. Waiting for 1 person. Okay. 2 people. All right, thank you. I've got one more thing to show you, and my music is starting to get on my nerves. So I'm going to stop it now, even though that was a big reveal, something that you might remember. All right. I want to show you how to handle it when the sides aren't nice numbers. They aren't 30s, 60s, 90s. So, yes, sir.
So this is only if the radius is 1. Right?
True, but 1 is a beautiful thing because it can be scaled up so easily. What if the radius was 3? Then you just got to take them all and multiply them by 3, see? All right, that's the power of using a 1 there, is it's easily scalable. Want it to be only half as big? Cut them all in half. All right, so right now, what I'd like you to do is find the homework for today. It's going to say day 1, and we don't know how to do all of it yet. We're not done yet. So I'm going to jump into the homework with you, and I'm going to encourage you to see if you can find today's assignment, day 1. And it's right there. Knowing that big chart is It's something I'm going to let you use as a crutch today, but within a few days, I'm going to give you a blank one and ask you to fill it all out. You can do it by calculating them with right triangles. It'll work. You just got to remember our old side ratios will have to be adjusted a little bit so that they fit the unit circle. In other words, we've got to divide by 2 on the 30, 60, 90. You can do them that way, but if you could just get it memorized, that'd be awesome. Then you'll have access to the unit circle for as long as you can memorize that table. And it'd be pretty handy. Like right now, they want me to find the exact value of the cosine and the sine of pi over 4. If I just had that table, wouldn't it be incredibly easy? Okay, but what if I don't have the table? What if I just need to recreate that real quick? Pi over 4, that's 1/4 of a pi. Do you get that that's right here? That's where 1/4 of a pi is? Does that make sense? And then if I only knew this spot right here was what comma what, it would have the sine and the cosine built into it, right? Sine what? Sine goes with what? Sine y. Sine y. Cos x. Okay? Sine y. All right, so I now need to know if this is a pi over 4. Wait a minute, that's a 45. I know this one. 45, 45, 90 is a 1, 1 square root of 2. But wait a minute. That's not working with my whole unit circle theme. So what do I have to divide it by? So that the radius will actually be 1. Divide it by the square root of 2. Divide it by the square root of 2. Divide it by the square root of 2. And now it turns into a 1 there. Why did I need that to be 1? Because it's supposed to be on the unit circle. And then, what's the x of it? It's this distance, which is what? 1 over root 2. What's the y of it? 1 over root 2. And therefore, what is the cosine? Cos x. What's the cosine of pi over 4? 1 over root 2. And I hope you're looking right here, because that's cosine is the x. And what's the sine of pi over 4? 1 over root 2. All right. Do you get how you could do this whole front page based on what we just talked about? What if the angle was negative 13 pi over 2? It's just a place. You can get there any way you want. I'd like you to try right now to make me a little circle and then count out by counting by pi over 2's. Where would negative 13 pi over 2 be? Here's negative 1 pi over 2, by the way. See what I'm doing here? It's negative 1/2 of a pi. Negative 1 pi over 2. Negative 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Do you get I'm actually down here? Now that I'm down there, wait a minute, Mr. Server, you've gone insane. I can't draw a triangle by drawing a vertical line from that. You're right. That's why my little things come pre-numbered with these spots. Do you get that that's 1, 0? Do you get that that's 0, 1? Do you get that this spot here is negative 1, 0, and this spot here is 0, negative 1? Why do I care? Because it's sine y. What's the sine of 270? Or the sine of negative 13 pi over 2? Sine's the y of it. Negative 1. Sine y. What's the cosine of negative 13 pi over 2? 0. So if you can't make a triangle, it's actually easier. Because if you can't make a triangle for it, you know it's just a combination of these numbers. So let me ask you a few. Everybody right now, stop doing your homework and answer this for me. What's the sine of 90? Wouldn't it be handy if all these points were in there? That's why I gave you that little set of ones there. You don't have to write them in. But I can take a second and go, okay, what is that? 0, 1. Okay, so what's the sine of 90? 1. What's the cosine of 90? What's the tangent of 90? It's 1 divided by 0, so therefore undefined. Therefore, there is no answer for that question. If you looked at a graph of it, there'd be an asymptote there. That's why you can't have an answer there. Okay, you have just learned more about pre-calc and trig in 1 hour than you ever have. I know, because I've been teaching you the whole time. That was a lot to absorb, and I'm pretty sure you didn't catch all of it, and that's okay. It's just the first day. I don't expect you to be a master by tomorrow. But the faster you can get this chart absorbed, I don't really need you to memorize it. I need you to be able to recreate it. And that's not the same as memorizing, because if I need to know, okay, well, one of these spots over here is kind of important. I know that. Well, I guess that's a 30. And then if it's a 30, that must be a 60, 90. And I can go 1, 2, and square root of 3. And then, wait a minute, but this is supposed to be a radius of 1. Oh, so I divide by 2, divide by 2, divide by 2. And now this point is what? And see what I mean? I can recreate it. I don't need to have it just plain old rote memorized. Now, some of you are actually really good at plain old rote memorizing, and it's not illegal. You can certainly memorize it if you want to. But if you can recreate it, that's pretty powerful. Once I know that this spot is root 3 over 2, comma 1, no wait, 1/2, sorry. Then I also know that this spot that goes with it over here is the same exact numbers, except one of them is negative. Negative root 3 over 2, comma 1/2. And so that's like a 30-degree angle here, but that means it's really for 150. So that's answering the question, what's the sine of 150? 1/2. What's the cosine of 150? Negative root 3 over 2. Okay, so anyway, I want you to do all of them up through 16. All right, because those are all things you can do just from the unit circle. Now I'm going to see how far I can get with you on this part of the assignment. See if you can handle number 2 with me. And I can do number 24 with you, which should take me 2 minutes, then you should be able to do number 25. Okay? If cosine is negative 2/11 in quadrant 3, what is the sine of that angle? Whoa, that's a complicated question. You know what? As soon as I draw a triangle for it, it won't be hard at all. So what I want you to do right now is everybody try to draw the right triangle that is involved here. I know I'm in quadrant 3. Do you know how the numbering goes on those? 1, 2, 3, 4. Okay, so I'm in quadrant 3. Okay, so I'm down here. Oh, sorry, hit a wrong button. I'm in this quadrant right here. My triangle has to look like that in that quadrant. Now, how big this angle is could be debated, you know what I mean? But it's got to be some triangle like that. How big that angle is the question. Okay, so then would you agree that cosine being 2/11 is telling me adjacent over hypotenuse? The hypotenuse is 11, and by the way, by definition, as in we just tell you this has to be true, the radius, which in this case is like the hypotenuse, can never be the negative number. All right? Then this is negative 2. Negative 2 over 11. My question for you is, don't stop, just listen. Listen, stop. Don't make noise is what I'm trying to say. Listen. This side here I can figure out, because as soon as I find it, I just want sine of this angle, and sine is opposite over hypotenuse. I need this mystery thing over 11. How can I find the mystery thing? And I'll have my answer. Pythagorean theorem. A squared plus b squared equals c squared. All right. I want you to try to get through 25 all. Have a good day.